Okay, welcome to everyone, and today we'll be speaking about on-farm trials and testing, and especially about varieties, and we're gonna try and continue the conversation with Nick Fradgley. He's gonna introduce yourself.
Yes. So I'm Nick Fradgley. I'm currently a PhD student and crop researcher at NIAB, but formerly of ORC, and kind of had worked on organic plant breeding, but also kind of looking at the where kind of genetic breeding and kind of applied quantitative genetics can take plant breeding in a direction that you might want for organic plant breeding.
Perhaps one question I wanted to ask you, and of course to continue the conversation with the audience. I was mentioning this morning that sometimes farms and breeders are a little bit two diverging worlds, and from your point of view, know that you have the experience of having been my illustrious predecessor at ORC, and now you are deep into genetic research. How do you see the genetics and farming? Could they reconcile?
Yeah, definitely. Yeah, a lot of the time breeders like to have a single environment to select for, but it becomes a lot more interesting where you have to adapt the crop to lots of different environments, whether it's a different farm or a different climate, or if the climate is changing, you have to preempt how that's going to change in the next 10 years. But you can also kind of use information from farmers, for example, like participatory plant breeding. So like the on-farm trials where there's kind of knowledge and experience that farmers are using to say whether crops are growing well or not, that can add information on top of how you actually measure yield from plot trials, and can kind of work together with genetic models. So at NIAB we can kind of work out a model to predict what the yield is going to be of a crop in the next year based only on genetic markers. But if you use the right kind of information from field trials or from farmer evaluations, it can improve that whole process to make it kind of better adapted and better suited for that kind of target environment, such as organic farms.
And you were mentioning yield, and one of the criticisms that genetics and breeding have had is that they've been, at least in the past 6 decades, perhaps only looking at yield. And but your PhD is actually looking also at something else, kind of more on the back-end quality, and how these new tools can actually be applied to do more relevant and more participatory approaches.
Yeah, or it's kind of reconciling the trade-off, if you like, between quantity and quality. So if you look at kind of where wheat breeding is what I focus on mainly, where it's gone in the last 50, 60, 100 years of breeding, it's been more about increasing yield at the expense of quality. So like they kind of mentioned this morning, you can look at the yield trade-off against protein. So as you increase yield, protein goes down, and even among milling wheats, the protein's been going down as well. So the direction that's been going has only been going down on that negative correlated trade-off towards yield, and there hasn't actually been much progress to increase it above the line. So I see that kind of the approach of growing a modern variety is carrying on with that kind of direction, but growing something like a heritage wheat is going at the exact opposite, and is only going up to the top to increase the protein, but that's always at the expense of yield. So that's not necessarily getting you somewhere you want to be either.
So do you think there is more room than before in the future for farmers or even other people interested along the supply chain, bakers, millers, to be then involved actually in breeding, or in the future involved in the work that you are undertaking with your PhD now, for example?
Yeah, of course. Yeah. Particularly for like setting the quality requirements for like bread making quality. At the moment, it's quite a narrowly defined set of requirements like protein, Hagberg's, specific weight that breeders have to breed for, and they've done a good job of that to make sure it kind of fits what's required of them. But I think, for other kind of things for like artisan baking, is other like flavours or functional qualities that are going to be useful to breed for. So that can either be done.
I was going to ask a question.
Yeah.
Which is to the audience: is what do you buy crops on? Why buy a certain variety rather than another variety?
Weed competitiveness.
Okay.
With competitiveness.
Why would you buy a certain variety?
Flavour.
Sorry?
Flavor.
I think there's been a change over the last few years. I think 4 or 5 years ago, people would have been buying mainly for disease resistance and yield. Now I think there's weed control is one thing, and flavour is, there's other attributes. I think the organic grower is perhaps changing, readjusting their mindset around their selection criteria.
And so, Nick, you've done some research on weed competitivity. Well, if you wish. And have you looked at other traits? So that it's along the lines, like William's saying, that people are now looking for different traits than perhaps just yield.
Exactly. Yeah, there's a lot of kind of different traits that combine to make a crop competitive or not. And the most obvious way to see that is the difference between modern and old varieties. So, but that's kind of, a lot of the time these differences are confounding because there's hundreds of things that are different between modern and old varieties. But the most obvious thing is that one is tall and one's short, but that's not necessarily the thing that makes it competitive. So like Ambro mentioned this morning, like the early kind of vigour and tillering seems to be more important for competition than just being tall and getting away from it. So in terms of carrying on with modern breeding for high yield and reduced competitiveness, or the opposite of getting heritage and more competitive, you can kind of get advantages from both by selecting for the right kind of combination of traits, by working out how the genetics combine to do that.
Say what are some of the traits?
Yeah, like tillering, kind of early growth coming out of winter seems to be quite key to just get ahead of the weeds. And a lot of that is related to root phenotypes, but they're really difficult to measure. So being able to measure enough varieties to get an idea of how that's working is, no one really knows if that's really the case yet.
What about actual, you see some wheats which are quite recumbent for quite a while, well, for differing amount of times before spring. I mean, the leaves spread out across the ground, and then at some point they come up, but it changes quite a lot from one variety to another, whether they do it at all, and then at what time they come up. So is that mainly? I've always thought that was mainly protection against snow. But does it have any other effect on competition with weeds and so on?
The passage from a completely flat habit then to completely erect, something I have seen especially in Central European varieties actually.
I call it the juvenile growth habit, which I think that kind of relates to the tillering ability. Like the ones that are kind of prostrate are going to put out more tillers before winter, but then the risk is that then you put out too many and then they die off over winter, and the crop will lose energy by doing that. But so it's all a kind of a balance of trade-offs between doing that at the right time and flowering at the right time to compete with weeds. I wouldn't say there's one trait that's you're going to look for. There's a lot of traits that need to be combined for that.
So, just so that you all know, the reason we're here is because I wanted them to talk about crop varieties, and John's got some variety trials here. But one of the things I wanted to ask was the different approaches to farming, so different tillage, direct drilling, whatever, and how certain phenotypes or certain varieties will respond. Is that something that can be looked at? And is it something that we can draw conclusions from to help farmers then select varieties?
Nick, you want to?
People have kind of looked at management by genetic interactions. So if one variety does better at at reduced tillage or in a ploughed environment, but it's really inconsistent. You don't often get the same kind of result in 2 different years, so that makes it really hard to breed for, because if you select something one year, you don't get the same thing the next year. But people can kind of suppose that in a reduced tillage environment, the organic matter is in the top layer of the soil, so there's more phosphorus at the top, so you want roots that explore that top layer better, which you can kind of measure a bit, but it's really hard to prove something like that exists, so it's a hard job to do that, yeah.
So I may add that there's for some aspects there needs to be patience, because sometimes the evidence is very hard to obtain, but we can get some we can get closer to it by putting together farmers' own trials and see what can happen. Perhaps in much more realistic way than doing an experiment anew somewhere else. Is there any Stephen, time-wise? How we?
5 minutes.
Yeah.
Just is there any elements of genetic engineering or modification that we shouldn't worry about in agricultural production?
That we should or we shouldn't?
That we should be okay, happy with?
Well, it depends, I suppose. I'm not going to have opinion on genetic engineering or GM.
Why not?
Because it completely depends on that exact case. Depends.
But is there anything that we should be? Is there anything we should be worried about then?
We should be worried about or shouldn't.
Well, either.
Okay. Well, I suppose for organic farming, the thing to worry about would be intellectual property rights of things that are, things that become GM. There's a lot more protection over the seed, but that's
That'd be true for all farmers.
yeah.
That'd be
Well,
true for all farmers.
Organic farmers would care about it more.
Rothamsted seems to be pushing the idea they want to get into gene editing, and I think they're basically talking about CRISPR editing. But I mean, I've read case even CRISPR editing has a margin if some things can have the same marker, and they don't necessarily know what it is you've edited. You know that you've edited the thing you wanted to edit, but you might be editing other things at the same time without noticing it. Is that true or not?
Well, he's not here to answer that question. So can I ask you, how do you find the phenotypes that you then select? Because you're not using CRISPR, but you are looking at the genetics.
Yeah, I suppose I'm coming at it from the complete, in the other direction. So like a molecular geneticist who does GM or gene editing would find a gene that they think does something, modify it, and then hope it does what they thought it did. So I kind of go at it the other way and find the phenotypic, the trait variation to start with, and work out how evolution and genetics can shape that trait and how you can drive that in the way you want, which is the same as any kind of natural or selective breeding.
Can I just throw not completely different, nearly completely different. There is an increasing amount of evidence to suggest that epigenetics, the effect of the environment on the genotype, is really important if we're going to get resilient crops, but we have to then home save our own seed. Thoughts, please.
I'm really, people overblow the novelty of epigenetics, which I think you're confusing with genotype by environment interactions. So epigenetics it's not changing the actual, no genetic differences are changing, but the expression of that change is based on the environment of the previous generation.
Yeah.
But people find that and get excited about it because scientifically it's cool. But the amount that the difference that it makes is pretty tiny compared to the genetics itself. But in terms of interactions, like one variety doing well in this environment but doing differently in another environment, that effect is huge and is either an opportunity or a complete headache, depending if you can predict it or not for breeding.
So we shouldn't worry about it.
You shouldn't worry about epigenetics,
Right.
unless you're really hardcore genetics. But you should worry about genotype environment interactions.
Yeah, no,
Yeah.
I understand both of them.
Okay.
That's two separate things. I just didn't express it very well.
Okay, sorry.
the whole idea of populations, which is something that probably both Nick and myself have been brought up with, was about having a huge diversity of genetics into the crop, and then sowing, harvesting and resowing it, it would adapt to the local environment. So actually making the most of the genotype environment interaction. I would say there are two components in it. One is the choice of the parents, that for YQ Martin Wolf and colleagues made very carefully, and the other one is having the right techniques for multiplying the seed organically, so that actually you are reproducing the seed and you're not reproducing diseases. Is there anything else you want to say about this yourself?
Yeah, I suppose maybe what you're guessing at is thinking about the population of the YQ, that it will evolve and adapt over time, which isn't epigenetic, that's just kind of adaptation.
But it's this thing
Yeah.
about it's this thing about the seed biome, which is more epigenetic, isn't it? And the effect that the biome has on the crop. So that comes from the parent crop.
Yeah, well, that's not epigenetic. The biome is still the environment on the actual seed.
Okay.
So unless you're changing the gene expression of the genes in the wheat plant, you're changing the microbiome, not the expression. So it's not epigenetics, I'm afraid. But the microbiome, that's also really interesting.
Really important.
Yeah.
Right now, any last question? How much time do we have?
Well, on that question, that I think it's easy to get confused between like a population which is going to reshape itself and adapt itself to a farm, and like an actual variety that has some sort of plasticity or whatever of response to the environment. But I think that when people talk about a population adapting to a particular farm, I think they start to forget that in traditional landrace practice, there is very often a methodology and a process by which, if not all farmers, at least some of the farmers using that landrace do an ongoing selection, so that not only does the crop actually fit the farm, but it continues to, or gets better and better at actually providing what the users want from it to make some particular product. And I typically doing studies of place in Ethiopia where they do a land race. There'll be some farmers that other farmers go to for seed. They may have some particular part of their land which they grow the seed of the crop on, which affects it, and so on. So I think we shouldn't forget about that. I just think we plant a population and it adapts, and that's it.
You were involved in something similar with the YQ population, were your last years at ORC, selecting lines from a population in that case.
The really neat thing about something like the YQ or populations is that you can use that diversity and drive that the way you want it to go by making farmer selections like they had done for thousands of years. But now I suppose you can look at kind of scientifically how that's evolving and how that would adapt to the farmed environment. So when they looked at kind of the genetic evolution of the YQ over several years of growing it, they looked at several genetic markers, and nearly all of them had reverted to what they call a wild type, which is the opposite of what breeders had selected for. So given a chance and you let it evolve under natural selection, it just turns back to a wild plant, which isn't exactly what you want for getting a good yield. And the kind of the reason behind that is that the crop starts competing with itself to outcompete its neighbours, and ecologists call that the tragedy of the commons, where everyone's competing too much and the whole crop itself gets a penalty. But on the other hand, if you kind of select it in the right direction for plants that complement each other, you would get a kind of a mutualistic, symbiotic relationship between individuals in the crop. So it's really debatable whether it's going a tragedy of the commons or a communist utopia.
We hope for the second.
Yeah,
and probably we will rather start and playing with breeding, or like the farmers Andrew was mentioning, spending often days and nights talking and arguing about which are the best years to seed next year and next, or at least this one, a lot of the story that we heard. Any other comments from this side?
overcome the propensity for the mixture to revert to smaller seeded varieties?
We tried. When back at ORC, we tried doing mass selection for grain size, density, and colour. So you did that. We sent it off for grain cleaners to do that on a gravity table. So we had like several fractions of the same population, and then sowed it against each other the following year, and they looked almost exactly the same. And then harvested that from the next year, and it went almost exactly back to how it was, because within one ear you get large and small seeds, so you're not selecting between plants, you're just within the same plant. So it's hard to do, but yeah, a little bit of manual selection by the farmer could easily do that by selecting some good ears that had bold milling grains.
So selection of plants from the ground, also considering that the careful selection and sieving of the seed for resowing, also considering that bigger seeds has been proven that have just for the size they have higher early vigor, just germination vigor, so all good things, especially in organic farms, and all sort of things just to make that the seed becomes more part of the farm ecosystem or organisms than we're used to. So I think we can close on this. Are any other comments?
No, one last question.
One last question before we start doing silly things in front of the cameras.
Yeah, go on then. You just suggested there that all populations will revert to smaller seeded wild types. All populations, or is YQ an exception because of the early work that was done selecting it? Has it set it on a better path? Is it better in some way because of that early work, or is it always going to gravitate towards?
No.
I think it would depend, but I don't think the small seeded thing is like the main way it's going.
They get taller.
Yeah.
And as long as we clean seed on a gravity table.
No, but that's.
I imagine it doesn't help.
Yeah, I don't think that's going to do anything, I'm afraid.
The YQ, I know, the YQ, as far as I know, only had one amongst 16 parents, which were actually.
20.
But there was only one that was truly pre-Green Revolution.
Yeah.
Is that right? So then, but as a whole, the whole population has got taller.
It has got taller, yeah.
Disappear.
Yeah.
But I think, to get a good complementary mixture, you want both talls and shorts because they're using the canopy differently.
Anyway, one of the lessons is perhaps also that there is no one size fits all. So population are a great tool to be used. They are not going to substitute pure line varieties necessarily. The good thing would be for farmers to decide on their own what is the best combination of each, and then build the future from that.
Yeah.
And that's a great place to leave it. There is not one size fits all. Shall we move to the soil pit?